All right, hey guys, and welcome back to Mr. Cole's little virtual classroom here. All right, so we started the last video with a little discussion on balancing equations, and it's rooted in this concept that you cannot create or destroy atoms is what we're looking at, or we can't create or destroy matter. So when we take a look at this, and we did this last time, well, you know what? Now that I'm sitting here improving, we did not even balance that introductory equation from last time. Let's do that real quick. Let's write it out. Hydrogen gas, and now if you did have a picky teacher, they would probably make you write these phase labels. And wow, look at all that terrible doodling the palm of my hand is doing. Hydrogen gas plus oxygen gas yields, and I'm running out of room, H2O, and that will be a gas as well, I'm sure, because of the temperature of which this reaction would take place. Now, I do not require students to write the little G's and all that stuff, but hey, just depends on your teacher. Let's do this. Let's make that T-chart I talked about last time. So I've got a hydrogen. You should be able to scroll. This one's so easy, I can do it without looking. Well, cool. Stop looking. Fast forward the video. And we should have an H and an O on the right. And now we'll count. There's two H's on the left, and there's two O's on the left. And on the right, and here's the problem, there's two H's and only one O. To have a truly balanced equation, these have to balance. There's two ways we could do this. One, remember, we can't change the equation. I can't add a 2 in here. But what I can do is this. I can add coefficients to the equation. So I can add the number 2 in front of this. And this is where somebody will mess up. They'll go, ha-ha, I solved it. 2 times 1O is 2. Look, the equation is balanced. Actually, you haven't. You've kind of jacked it up. Because you are right in saying that 2 times 1O is 2. So you balanced out the O, but in the process, you also have to know that that 2 changes this H2. 2 times 2 H's makes that a 4. So now we have to consider, okay, well now my H's is unbalanced. I've got 2 H's on the right, but I've got 4 H's on the right, and I've got 2 H's on the left. So it's easy. I need that to become 4 so that it matches the other side. Well, what can I multiply 2 by to get 4? Well, add 2 for a coefficient here. Now, somebody will say, now, does that screw up this oxygen? No, the plus separates these coefficients. So the only thing this 2 changes is what's directly behind it. So like this H2, 2 times 2 is 4. And now balance the equation. Now, you should be going, well, Mr. Cole, is that the only way to solve that equation? No, there's always more than one way to solve the equation. You'll know the other way, and like I said, some people don't like it when I throw the halves around, but the other way I could have solved it would have just been to have done this. To have added a 1/2 in front of the O2. What's half of 2? Half of 2 is 1. The equation is balanced. Now, for the purpose of doing the stoichiometry, this works. There's no problem with this. But you may have a teacher that will not allow you to use halves, or you could be using like a Blackboard-based program that won't allow the input of fractions. All you have to do to get rid of your fraction, once you know you've balanced the equation, get rid of the equation, multiply everything by 2. So multiply that by 2. 2 times the half cancels it, and then multiply this by 2, which was our other answer. So you're able to knock that out very easily. All right, well, let's get on. That's 4 minutes in. We haven't really worked a new problem. So here's number 2, and if you notice, I have not even finished writing the reaction. I want you to. You've got a compound and a compound. What kind of reaction do you think this is going to be? Well, it's going to be a double replacement. And here's the thing, what's going to happen is quite simply the calcium and the hydrogen are going to trade places. But I need to do something. Calcium is a +2, and then it's going to trade places with the hydrogen. So the calcium's going to pick up the SO4. Well, SO4 sulfate is a negative 2. Well, it just so happens that's beautiful. Plus 2 minus 2, I don't have to do anything. Plus, and again, I like writing these big, so I've got a lot of room here. So now the hydrogen, and this is where somebody will mess up. They want to try and bring the OH2 over. Remember, this 2 is here. It goes back to the last unit you learned. OH is hydroxide, and it's a -1. So that 2 is only here to balance out this chemical formula. On the other side, the only thing that's going to the other side is the OH. Well, what's so beautiful about that, Mr. Cole? +1 -1. That works out perfect. Plus, I also know, and by the way, this is a little trick to balancing equations. I know that HOH is H2O. Simplifying the equation to H2O is actually a useful trick in balancing equations if you get stuck. Say, for example, a little trick. Sometimes, I'm going to go down here to the bottom of the page. Sometimes you'll see a problem written out for, like, it'll be written like this. And so it'll be written in like an organic chemistry style. And you'll go to balance the equation, and that's kind of a pain to balance. So a little trick you can do is rewrite that to say C3H8, which is propane, and it actually makes it easier to balance the equation. Again, if your teacher's like nitpicky, when you're finished, you can write that equation or that formula back if you want, but it's easier to write it condensed like that. So there we go. I'm going to take care of that. Now, again, that's just a nifty little trick you can use to, and that's all balancing equations is. It's how good is your bag of tricks. Well, let's do something. Let's go ahead and do this. So the first thing I'm going to do is write my T out on my screen. And I'm going to write down all the elements. So I've got calcium, I've got oxygen, and what's next? It's hydrogen. Then I've got hydrogen again, but I've already written hydrogen, so I'm going to just list each element once. And then I've got sulfur and oxygen, but I've already written oxygen. So I've only got 4 elements in this problem, and now the goal is to try and make those balance out inside the problem. So the little check, make sure I've got the same 4 elements on the other side. If I don't, then I need to do some work here. So let's start doing our counting now. Can I switch to like a blue? That'd be beautiful. So count calciums on the left. That's my question. You should be doing this with me. How many calciums are on the left? Well, there's 1 calcium on the left. How many oxygens are on the left? All right. Remember this parenthesis, how it behaves is this. There's 2 times 1, there's 2 oxygens here, plus there's 4 oxygens here, so that's a total of 6, and I hope you understand that. 2 times 1, that's what these parentheses, it's just like in math class. These parentheses, 2 times 1 oxygen is 2 oxygens, plus the 4 gives us 6. Now let's look at hydrogen. 2 times 1, we have 2 hydrogens here, plus these 2 hydrogens means we have a total of 4. And then the only thing left is this sulfur, and we've only got 1 sulfur. Now, do the right thing to the other side. Quick, pause the video and do the other side before I start talking. Okay, I'm starting talking. So on the other side, we've got calcium. There's 1. There's oxygen. There's 4 and 1, which makes 5. Hydrogen, I've got 2. And sulfur, I've got 1. So now you've got to make a choice. Time to balance this equation. I've got the calciums are good, the sulfurs are good, but I've got 6 and 4 on this oxygen hydrogen thing. So I've got some imbalancing here. So now the goal should be, you should be freaking out a little, going, Mr. Cole, how do I know which one to pick first? Do I choose oxygen or do I choose hydrogen to balance first? Here's another trick to working these problems. Whenever you're like confused about going any, mini, miny, mo to pick one of these things, I don't even know if kids still any, mini, miny, mo today. Here's a little trick though you can do. This is a nifty little trick and it so makes these things easier. Answer this question for me. How many times do you see the letter CA? I'm not talking about the 4s and the 2s. How many times do you see the letter CA in the problem up here? I see it once there and once on the other side. So I see the letter CA twice. And notice how I'm writing this off to the side. How many times do I see the letter O? 1, 2, 3, and 4. So I see the letter O 4 times. How many times do you see the letter H? 1, 2, 3. How many times do you see the letter S? 1 and 2. Here's what it tells me. Whenever I'm trying to pick one to balance first, and this can make hard problems harder, pick the one you see the least number of times. Now, calcium and sulfur balance. So that means out of the choice between oxygen and hydrogen, I pick hydrogen. So I'm going to pick hydrogen, and I've got 4 on the left and 2 on the right. So here's my question. What coefficient, what can I multiply by 2 so that I end up with 4? Well, what times 2 is equal to 4? Hey, I love this one. 2. 2 times 2 changes that to a 4. But now go back up here. Don't forget that 2 not only multiplies the hydrogen, it multiplies the oxygen. 2 times 1 oxygen is 2. 2 plus 4, that's where somebody will mess up. They forget to add back to this 4. So this is really 4 plus 2, because there's 2 oxygens there now, which means that's not 5, that's 6. And now if you look, 1, 1, 6, 6, 4, 4, 1, 1, this equation is balanced, and all it took was that 2. So I'm going to shut this video off and do a last one where I promise I'll do a few more than these. But anyway, later. Bye.